Hello, welcome back. We have here today a problem of moment of inertia. We are given a composite shape and we are asked to solve or calculate the moment of inertia. As we can see, we calculated in the previous video, we calculated the centroid of this beam. And we noticed that the centroid along the y-axis is not in the center of the height of this beam because the beam is not symmetrical. That's along this height, the beam is not symmetrical. But this way, along the x-axis, the centroid is symmetrical. The centroid is right in the center of this beam. As a result of that, we went through the whole procedure to calculate the centroid along the y-axis. And so we are going to need that centroid to calculate the moment of inertia. And because of that also, we have three rectangular shapes that form this beam. So we know the formula for moment of inertia for a rectangle is B H to the power 3 divided by 12. So for a simple rectangle, that's the formula you need to solve your moment of inertia. But because we have a composite shape that is not symmetrical, we have to delve into a theorem that is called the parallel axis theorem. Parallel axis theorem. And that parallel axis theorem says the area of a shape multiplied by the square of the distance between the overall centroid and the centroid of the particular shape we are dealing with. So in this case, since we already know the centroid of the overall shape as 7.39, so we want to calculate the centroid, we want to calculate the D for each of these shapes. So let's do that very quickly before we move forward. So for our first rectangle on the top, the centroid of this shape from here is 12.75 because the overall height is 13 and this is ½ inch. Half of this ½ inch is 0.25. So you minus that 0.25 from 13. That is 12.75. All right. Now that 12.75 is greater than this centroid. So you minus this centroid from that value. So for our D1, it will be 12.75, which is the centroid of this shape, to here, minus this value. And that will give you 5.6 inches. All right. For our D2, that's this shape here, the second rectangle. The centroid of this shape from this bottom is 12 inches divided by 2, that's 6, plus this ½ inch, that is 6.5. So that was 6.5 minus this 7.39. You are going to have a negative 0.89. Okay? And then for our D3, it will be, this is ½ inch from here to the middle of this rectangle. That will be 0.25. So 0.25 minus 7.39. We are going to have negative 7.14. Now don't worry about the negative. As you can see, that the distance d is squared. So when you square it, the negative signs disappear. So we know this. We know what those values are. So we're going to need that value to be able to calculate our moment of inertia. So let's just take this out. Just bear these values in mind. So the moment of inertia of this shape, which is, I will call it the total moment of inertia, will be the moment of inertia of the individual shapes. I1 plus I2 plus I3. Okay? So let's start with our I1. You plug it into this formula. You plug your value to this formula. Our B is 10. 10 multiplied by h. H is half inch raised to power 3 divided by 12 plus our parallel axis theorem. The area of this rectangle is 5 because 10 multiplied by half inch, that was 5. We already calculate D. Our D1, we calculate it to be 5.36. You square that. Then our I2 will be our H, our B is half inch, 0.5 multiplied by the height of this rectangle, which is 12 raised to power 3 divided by 12 plus the area of this rectangle is 12 multiplied by half, that's 6. And we also calculate our D, distance D, as negative 0.89. You square that. And then our I3 will be, our B will be 6. H will be half inch raised to power 3 divided by 12 plus the area of this rectangle is 3 because 6 multiplied by half, that's 3. And we calculated our distance D to be negative 7.14. You square that. All right. So when you do this maths, you are going to have 143.7 inches to the fourth here. Here you are going to have 76.7 inches to the fourth power. And over here you are going to have 153 inches to the fourth power. So that's the moment of inertia of the individual shapes. But your overall moment of inertia, which is what we are looking for, is the sum of all of this. And when you sum all of that together, you are going to have plus 76.7 plus 153. You are going to have 373.4 inches to the fourth power. That is the total, that's your overall moment of inertia for these shapes. So a very crucial part of this problem is to understand how to calculate your D. So when you calculate D, don't worry about the negative sign. The negative sign will disappear by the time you square that value, whatever it comes to. And then the sum of all of that is your overall moment of inertia. Please go through it again, watch the video again, and feel free to comment and like this video. Thank you for watching.